Induction, I will explain about the theory of this experiment. Faraday's law of induction states that the rate of change of magnetic flux through a loop is proportional to the magnitude of EMF induced in the loop. The relationship is EMF equal to d lambda over dt. The lambda is the magnetic flux linkage, and n is the number of turns, and phi is the magnetic flux through each turn. From this formula, we also can say that the number of turns of the coil and the speed of the magnet will affect the induced current. Besides, we have second Faraday's law of induction state that the induced voltage in the circuit is proportional to the rate of change of the magnetic flux. So the faster the magnetic field change will result in a greater voltage in the circuit. Next will be the electromagnetic induction. It is known as Faraday's first law. It is the process by which current can be induced to flow due to a changing magnetic field, and it was first discovered by Michael Faraday through an experiment. So from the experiment, we propose that the movement of permanent magnet back and forth towards the coil will generate induced current, which signifies the presence of EMF. Besides, there is another law described electromagnetic induction, which is known as Lenz's law. The negative sign indicates that the induced electric current flow in a direction such that the current opposes the change that induced is. According to the Lenz's law, if a magnetic flux increases, a magnetic flux in opposite directions will present to cancel out the change.
So the objective of Faraday's law is to investigate the relationship between the number of turns in the coil and the magnitude of the electromotive force EMF. Next is the hypothesis of Faraday's law. First, the higher the number of turns of the coil, the higher the current can be induced to the circuit. Second, the faster the speed of cutting the magnetic flux, the greater the current can be induced to the circuit.
Hi, I'm TEOH. Now I'm going to bring you together to conduct the experiment of Faraday's law of induction. These are the materials you will be needed. Most importantly, you will need to have any kind of wire and a multimeter, a magnet, and cardboard, and some tape to secure the wires, and also a stick to mount the magnet onto. And here I have made my coil. This is the coil that made out of 200 turns, and this is the coil that has 30 turns, and then this is the multimeter set to 2000 microamps ammeter. Okay, then as I put this into we can sense some current flow. There is some current induced into the coil. It has maximum of 5 microamp. Yes, it has the maximum 5 microamp. Then I will switch to the 200 turns coil. Let's try again. Hence, we can conclude that the higher the number of the turns of the coil, the higher the current can be induced into the circuit. And what if I vary the speed of cutting the current? As it's slow, is less current, and if faster, I can have the greater induced current. And what if I just put it in and run the magnet? It will hardly generate any current. Yeah, that's it for the experiment of induction for Faraday's law.
Hello everyone, my name is TING, and I'm going to show you about the application for Faraday's law electromagnetic induction. Faraday's law of electromagnetic induction is commonly used in our daily life, but the most common use in our daily life device is electrical transformer. What is transformer? Transformer is a passive component that transfers electrical energy from one electrical circuit to another circuit or multiple circuits. Transformer consists of a piece of iron with two separate coils wrapped around it. One coil is called the primary and the other coil is called secondary. Transformers are commonly used for increasing low AC voltage with high current, which called a step-up transformer, or decreasing high AC voltage with a low current, which is called a step-down transformer. Transformer can also be used for isolation, where the voltage in equals the voltage out, with separate coils not electrically bounded to one another. Transformer can be used in two mainly different ways, which is one, the electrical power transmission. Transformer allows transmission of electrical power at high voltage. This will reduce the loss of electricity due to the heating of wire. By this, we can allow the generating plant to be allocated at a distance from the electrical consumer. The electricity had to pass through many different transformers before it reached the customer, as we can see in this image. Another area is the transformer can be used in electronic devices. Transformer is used to convert voltage from the distribution wiring to convenient values for the circuits. That's all for me. Thank you.